Our next laboratory exercise is Lab 5, OpenGL, Index Buffers and Animation. So this is our handout. In our previous lab, we finished drawing of these three triangles. And to make this drawing, if you recall, we had uploaded two arrays, 9 vertices and 9 colors for each vertex, and our model C++ class uploaded this information to the GPU. At the same time, some of the vertices are shared between the triangles. And in this laboratory, we will explore this idea of assigning an index to each vertex that participates in this object creation. For example, we could describe our triangles using these indices as follows. Starting at the top, 2, 1, and 4 form a triangle using these arbitrary index assignments. Then the middle triangle can be described as 1, 3, and 4, or arbitrarily you can use any sequence of these numbers. For example, we could start with the 4 and go to 1 and then to 3, and that way describe this triangle. The important thing to remember is to keep the counterclockwise winding order when specifying the triangles. Right, so this allows to specify front faces and back faces of our triangles as recognized by OpenGL by default. So if we're using this new index idea to describe these three triangles right here, we would have to specify only 6 vertices to describe them. Right? So this is 0, 1, 2, 3, 4, and 5. Altogether 6 vertices. So when there are thousands of triangles, indices can save a lot of memory and they may require less processing power from the GPU to process each vertex. So similar to a vertex buffer, which is bound to an array buffer type of target, OpenGL also supports index array buffers specifically designed for this purpose of vertex indices. And so we can feed them as vertex attributes into the vertex shader, which will process the order of each triangle based on the order of index. So if we use this example of our 4 triangles and construct a set of indices, then we can upload this array to OpenGL hardware by using the following code. And we begin by specifying vertex array object, essentially requesting an array facility from the GPU. Then we also declare an index buffer object, which is another integer, which will become a handle for the memory that will hold our array of indices. Then we need to make a call into generate vertex arrays, and that populates the vertex array object with unique integer value, which now identifies our array. Generate buffers prepares our index buffer object to allocate memory in graphics hardware. Then we say that we're now going to use this vertex array object. Binding essentially means using or using it now. For vertex indices, we're using a different constant specifying that this will be not an array buffer, but the element array buffer, which really is telling OpenGL that this will be an array of indices. And we use index of the buffer object to make this request. And then we can upload our actual indices by telling OpenGL how many indices we have, specifying the address of our indices, and also an option to tell the hardware that this is static draw, so the indices should stay in GPU memory for the duration of the entire program. And when it's time to draw the triangles, we're going to use this OpenGL call, draw elements. We're going to request triangles, specify how many indices of triangles we have, and then tell the hardware that this is an array of integers. Before the indices, the original rendering call was GL draw arrays.